Hey guys, today I'm going to be recording my system design interview practice. So today I'm just going to go through a quick 30-minute attempt at designing a simplified version of Twitter where people can post tweets, follow the people, and favorite tweets. So this is just based on a great resource which I'll link in the YouTube description. Hired in Tech, they have a great companion or sister course to coding interviews as well. And one of the big recommendations they give is to just practice like these types of interviews. So write out yourself, try to figure it out without repeating things you read on scalability articles or from course material in preparation for system design interviews. So a big one of those courses would be Grokking the Systems Design Interview, and then also there's Systems Expert as well. But yeah, I'm just going to go into this like semi-blind, like I haven't looked at this case study in a while. But yeah, let's get started. So I have allocated 30 minutes to answer this question, and I'm going to just kind of be the interviewer and interviewee. And then once this is done, I will try to see what I create, and I can kind of reflect on lessons learned here. So let's begin. Alright, so today's question is to design a simplified version of Twitter where people can post tweets, follow other people, and favorite tweets. So some of the things I consider immediately are how to basically better define this question. So for me, one thing I'm noticing from this statement is a lack of the Twitter timeline or newsfeed, if you will. So I would probably clarify that with the interviewer. Are we also designing the Twitter timeline or newsfeed feature? So from this, I'm guessing we probably aren't. And then also something else I would additionally ask is, for this, are we also considering multimedia components into our tweets? So are we including photos, GIFs, videos, links to other websites, so maybe like short links to other websites. So let's say, just for the sake of this video, we will also be considering the data storage components for photos and videos, and the GIFs can be included there as well, but there will be some form of multimedia for our tweets that we should consider. For the purpose of this interview, we will not be doing necessarily the timeline or newsfeed feature, so don't worry about this. Then I would also ask the interviewer and pay attention to their words on if we have to worry about anything like login, authentication, verification. So do we have to work on user authentication, sign in, verification? And then probably the only user authentication we'll have to deal with is our API dev key for the post tweet API dev key. And that's something I would also clarify with the interviewer. Hey, or I won't say hey, but is the scope of this design focused on a backend service such as tweet API? So the reason I say like the tweet API is because when it says design a simplified version of Twitter where people can post tweets, that's the big thing. Follow other people. So that's probably going to be something user related. So I would kind of clarify that. How do we track following other people? So that'd probably be some type of relationship, and then favorite tweets. So that's probably some other metadata we can include with tweets. So I would probably just like get confirmation that we will be focusing on two main important parts of data. So the first two are user relationships /actions, and then also tweet metadata and content. And I'll probably draw out some tables. I might have 2 to 4 because I think you can easily do following relationships in general on just a small like one-to-one table. But I might have to look into that a little bit later. But the general flow, from my understanding, the like functional requirements are. Let me add a new text box right here. Functional requirements. Users can post tweets. This is something to be asked like, hey, should we worry about on our API design modifying the tweet? Modders can modify tweets, which includes metadata. So what I mean by that is like the follow, the heart. Or that could be a separate table. I'll look into that. Let's see, users can follow other people, and then users can favorite tweet. Okay, and then non-functional, I'll probably ask like, what do the customers care more about? Is it, do they expect like once a tweet is tweeted, like it can never be deleted? So if that's the case, maybe we need some replication. And then also, how highly available can the system be? Is some downtime acceptable? If so, how much? Probably for a big company like Twitter, downtime is not preferable. So probably less than 8 hours per year. So that probably be greater than 3.9 availability. So non-functional, and then latency is probably very important in terms of you being able to write your tweets, and then reading. I think we can have a little bit of leeway, especially with big accounts, and that'll probably be a part of a strategy we talk about. So non-functional requirements. Tweets once written will not be lost unless deleted by user. Low latency on writes, and there's probably acceptable latency depending, and moderate latency on reading tweets generated on newsfeed or timeline, which I think it's going to take care of itself, because we further up we define like the scope of this particular system design did not include the timeline. Let's see. Let's fix this. Okay, so from this, I would also include right here image and video components for data. Okay, so high-level design for me, I'm thinking you'll probably have separate databases for the tweets themselves, the metadata, and then also the video and photo storage. And then with that metadata, you could probably include or split in between those like the user and tweet metadata. So how would that look like? So let's say starting off you have your client. So this could be high-level design. We'll kind of break this up into the actual how the data model looks like, and then we can talk about the REST API too. So let's just look at time. How are we doing? Okay, we have 9 minutes. I mean, we've done 9 minutes so far. So from here, high-level design. Oops, not that. Shapes. There. So let's do like a little cloud for client. Okay, and then in here, client. Oops. And then let's just make that smaller. Oops. Okay. So we have our client. They visit YouTube. They can write, read. So from here, let's do a line. And then I think in between like our application servers, which will be right here, we'll probably want some proxies as well. So I will probably just do little circles for that proxy, to be honest. Okay, so that will be our proxy. Oh, and let me do like the little scribble line. Okay, proxy. Oh, wow. All right, let me undo that. I'll just do a text box for that one. Proxy. Okay, let me just move that. Make that a lot smaller. Okay, so yeah, we have all our traffic probably going for proxies because we're going to have a lot of applications in database layer as well. Oops. Okay, let's go back to the line. Okay. Okay, and then there'll just be multiple like proxies for application layers. So let's go back to our shapes. And let's go do like database servers here. So let's just, oh, I kind of like that. That's cool. So from that, now let's do our select. Oops. Okay, that's better. And let's do our scribbles again. And then we can do this one. And then that's our app layer. Oh, God. Okay. So this basically is going to handle like a different request. So from there, then it would go to our different services or different databases. So we're going to have a blob store for our file. I mean our photos and videos. So we'll have a little blob store there. Hmm. 1, 2, 3. Okay. So this top one will be our blob store. Blob store. So blob store is like something like S3 or Google Cloud Store that like stores this actual photo data. And actually, probably we would wanna use some like CDN. Oh, actually, we don't necessarily need like heavy video data, so we'll probably just use a blob store here. So And then we probably have a service in the middle here, like that gets the metadata first and then collects the things from the appropriate database. And then we'll have some cache as well. So actually, in between these databases is probably a cache layer, and before that cache layer, the actual metadata service that that collects the thing, the video and photo information from Blob Store, the user information at the appropriate time when you're looking at user information, and then also tweet information from tweet metadata. Okay. Trying to look for like a rectangle. I guess I'll just use this. Okay, I think I might. How do I make this bigger? Oh, there, perfect. Okay, maybe I just have to. Maybe view? How do I make this more available space? Okay, well. Alright, well that's fine. I will just have to move these a little bit to the right. Okay, so from this is going to be our metadata service. So from that metadata service, we're also going to have a little cache in between. So for a cache, we'll just use like probably like this symbol. So that'll be our cache. We'll use like a out-of-the-box service like memcache or something. Scribble. And then nothing there, then it just goes to Blob Store. And then everything essentially. So then we just get these text box is application layer. Then we have our metadata service. So, like, how does this metadata service work? I'm gonna show you below in like a little table, but text box, tweet, metadata service for retrieval. Oh, actually, just metadata service in general. Metadata service retriever. Okay, this is our cache here. Okay, so this is going to be our tweet. Oops. metadata. This is going to be our user metadata. Yeah, use metadata. And then this is probably like our follower metadata. Okay. Okay, and then just like quick little note as well. I should have probably talked about the actual calculations for the amount of information that we should expect in the system. So I'll quickly go over that. I'll go over the API design, and I'll go over the tables, and we can worry about bottlenecks there. And also the actual database design information as well. Okay, so let me just quickly do those calculations, database modeling, and then also the API calls. So, okay, so for the calculations, let's. I'm going to assume since it's such a popular service, we have 500 million daily active users. Out of those people, we probably have people. I want to say probably reading like 40 tweets a day. It's a day, and I think at most you're probably reading more. You're probably reading like 100. And then like for actually like writing a tweet, I expect besides the most like popular users, you're probably only maybe writing 1 or 2 tweets a day. So let's just say if it's like this example, like 2 tweets a day, writing 2 tweets a day. For like a typical tweet, you're going to have 140 characters, so 280 bytes. You're going to have some metadata there as well. From that metadata, you probably include like something like timestamp, user ID, location. So let's just say on the upper end of the scale, and then just a safe average like 500 bytes per tweet. And that's just your typical like text-based tweet. Now we also said we were going to do or utilize a blob store. So from that, I actually pulled up the Twitter newsfeed, and we can see that most of these are tweets, but we have an image here. So it seems like 1 out of 5 tweets has a photo, and then maybe 1 out of 10 tweets has a video. So if we were to include that, so 1/10 video and 1/5 photo. We can actually so for video, your typical, I think we'll do like 2 KB for video, and then maybe like 256 bytes for a photo. Okay, so with that, let's just say your average tweet is going to be, let's do this. So be 2.5 KB. So 2.5 KB times 10% plus 750 bytes times 25%, and then plus 500 bytes times that's 20% actually. 20%, and then the rest is going to be 70%. So based on that rough calculation, so we have 0.25 KB plus 75 bytes. So out of it, we probably have like 1 KB 1 KB per tweet, and then from those million users we said, so a billion tweets times 1 billion. Okay, so in the interest of time, we're just going to roughly say we're going to be reading a lot of tweets and then not writing as much, but it's going to be a lot of storage needed. So in this layer right here, there's going to be a huge amount of horizontal scaling, or essentially there's going to be a lot of replicas or sharding based on that. So we can talk a little bit about that, but let me just quickly get in. So let's just say roughly we're gonna have like maybe like 40K tweets. I don't want to get too rough numbers, but we're gonna have a lot of throughput with reading queries for tweets, and then not as much write queries, but it's gonna be still a substantial amount of data. So 1 billion tweets, so that'd be 3 billion tweets per month. And 30 billion divided by 2.5 million seconds. So you would basically, I think, have around, so you just cut off the 3 zeros. This would be 15, so this would be 15,000 read queries per second. And then the writing, that would be, just divide that by 2. Might be doing the math wrong, but let's just say this is going to be divided by 100, so we're actually reading 150, oh no, writing 150 tweets written per second. Okay. So now we should do the API. So we're just going to do a general API right here. So with this API, we'll just do like post tweet. So post tweet. We're going to have API dev key. We are going to have, oh, that's going to generate itself. So what information we need? We need user ID. We need something like date time. We also need tweet content, geo, location. Let's see, what else is included in tweet besides the content? Oh, multimedia. That'll be a bool. And we can do like favorite count, I think. Oh, no. If we're just tweeting that, okay. So now we're going to do read tweet, or like gather tweets. So I think from there, that's going to be like more like the timeline thing, but we could just do something like API dev key, follower list probably, and geolocation. So we can figure that out in a bit. General tables I kind of want to quickly go over. So essentially for a tweet, let's see how much time we have left. 2 minutes, okay. For the tables, I'm thinking more SQL, just because, oh no, since when would you need to actually gather all these tweets? Like for the newsfeed function, you'd probably do something by like tweet ID, and they have to be attached to the person, and that requires probably like a couple joins. So I can actually see, at least for these relationships, like how you would want to possibly do NoSQL, but I think just a general SQL database would work with some of these queries. In order to speed things up, you'd add a cache. Other things I would probably do to make sure certain bottlenecks didn't happen is for the actual tweet content and metadata. Well, actually, for the tweet content, I would probably shard the database on a tweet ID, maybe some other like time component as well, just because you wouldn't have any single like tweet overloading anything. If you had like a popular user and you sharded the database like that, then you might run into some issues. But yeah, I would probably add some load balancers. I would shard the tweet database, and I think this service really helps out, like splitting out the actual multimedia, the tweet metadata, and the tweets themselves. So let me just copy this database, and this will include like the actual tweet content that we're going to be searching up. So and tweet DB. Okay. Yep, and then if it's popular enough based on other users, we're going to have like those most popular tweets in cache. So we have like those high latency numbers. Um, yeah. Okay. So I think this is a general good approach. If I were to redo this, I would talk more about these calculations, the API, and the database design before I jumped into the high level overview. But it's good to know that I kind of jumped the gun with this high level design. So I focused a little bit more time on the calculations API and the tables to justify my overall high level design. So thank you guys for joining. I hope this was helpful. I know I took some lessons. One of the great ones I got from one of my friends, Victor, was just to be able to listen to the interviewer and if they're giving you any hints. So I definitely could have done better here, but I'm glad I'm getting this practice. So see you guys next video. I'm going to be getting some more mock interviews with Victor, and see you soon. Peace.